Hello students, welcome back. Previously, we went through a couple of examples on integration by substitution. Let's review those. Those are tricky. Oh, wrong cell. Yes. We did this one and that one. Let's review quickly, this time looking at the answer key. So here we go. This is what we want. So the inside is y, and we want dx represented in terms of y. So inside is y. Take the derivative, we get that. And then removing the denominator, we get this. And finally, solving for dx, we get the final expression. Traditionally, people skip this and then go directly to this and then that. Or if you skip this one, that's okay too actually. In any case, the key is red part and blue part. Substitution number 1 and substitution number 2. And if you do that, number 1 goes here, number 2 goes there, and then substitute and simplify this x, that x go out, and we have a y integral. It's a simple integral, just power function. So get the antiderivative here and substitute x back in. So after the third substitution, we get the final answer. Here's a review for the second problem. Okay, all right. This is what we want. And then inside, and then dr, we're going to find those out. So inside, take the derivative, and then ds is 1/3 r squared dr like this, and then solve for dr, and then substitute back in. Number 1 red, number 2 blue. Some people skip this and go directly to this one. Some people skip this and go directly from here to there. It doesn't matter which way. Now, if you substitute 1 and 2, red and blue, and then simplify, you get an S integral. That's an easy integral. Use a power rule, we get the antiderivative, and then substitution number 3. We get all expression back. Okay, can we do the same thing to the next problem? We have denominators and so on, so let's take bigger font so that we can read better. This one here and that one there, we need to substitute. Do you see why I got denominator here? What else is there? If you have big parentheses like this or something like that, it's obvious, but otherwise, it's going to be the denominator. You see, the numerator can be separated, so no big deal. Denominator, if you have denominator and there's some addition there, that usually is it. So z is y squared plus 2y. Okay, there you go. And that's going to be my first substitution. So derivative is 2y plus 2, and you have to solve for dy. C is 2y plus 2 dy. dy is therefore 1 over 2y plus 2 dz, and I guess we are ready. Substitution number 1, red. Substitution number 2, blue. Okay, let's go ahead. This one is Z, and this one is, well, as we have here. Okay, do you see a simplification here? Do you see this y plus 1 and 2y plus 2 somehow simplifying each other? You should. After all, the purpose of all the substitution is to get simple integral. 2y plus 2 is twice of y plus 1, so this entire thing becomes this. Integral of 1/2 1 over z and dz. Oops. Okay, 1/2 is just coefficient that pops out. 1 over z, what's that antiderivative? Do you see this log function here? Or you can see that this is actually z to the negative first power. Either way, you'll see 1 over z function there. So there's a review. Okay, we are ready to go with the final form. So this is a computation that you wanted. Copy and paste this. Come on, copy and paste. And that is this one, copy and paste. But this is a bit incomplete because what is z? Z is y squared plus 2y. Now that'll complete the problem. Okay. All right. This one was a bit harder because unlike the previous problems, the inside of the composite function was a little bit unclear. Still, we have the denominator here, so it's not that bad. How about the next problem here? What do I take as a substitution? Well, it's tempting to take the denominator, as we did before. But then again, here's a red flag. I mean, there's no addition or subtraction in the denominator, so it's not like we cannot separate or things like those. So that's red flag number 1. And red flag number 2 is, well, if you take the derivative, you'll see. Derivative is, we have to use what? Product rule? Well, this is getting way too complicated. By this time, you should have seen that this is not working out. After all, the purpose of all this substitution and all kind of technique is to get simple integral, and this will create something worse. So it's not working out. So you gotta select something different. What do I select? The answer is just log of x. Why? Because, oops, there are two criteria actually. One is the inside of the composite function. Another is there the derivative flying around? Let's go back to this reverse chain rule here. You see the derivative of the inside flying around, and yes, it does. We have 1 over x. we have 1 over x here. We have derivative flying around. And that's an indication to take y as log of x. But this was difficult observation to begin with. Suppose that we did, and let's do the derivative computation. dy is 1 over x dx. dx is x dy. Oops, what did I click? So that's blue, and that's red for this antiderivative problem. So that's red, and that's blue. Oops. Okay. All right. Let's substitute those in. Red is gonna be y. Come on. And this is gonna be x dy. Blue. Okay, did I substitute everything right? Substitution number 1, red. Substitution number 2, blue. All good? And do you see a simplification? Do you see this? You don't really have to do this. Okay, so what do I have here? Integral of 1 over x log of x dx is log of y plus c. But what is y? What is y? Y is log of x. So we have log of x plus c. Oh boy. It was a hard problem, wasn't it? Look at the previous problem. The inside function is the denominator, so that's where we start. And the derivative to get dy. Once that is done, substituting and getting the antiderivative and the third substitution are straightforward. How about the next problem? First substitution, y is not the entire denominator but log of x. Oh boy, that was hard to see. But once that is done, the derivative computation and dx, and then first and second substitution and calculating the resulting integral is not too difficult at all. And then, of course, the third substitution. Well, that looks a bit strange and tricky, but yeah, we have log of x. By the way, if you miss the absolute value here, I'm not going to take any points, so don't worry too much about that. But if you're working with some machine grader, such as WebAssign or something, okay, it may take some points off, so be careful. Okay, we went through a lot of example problems on integration by substitution. And we'll have a little bit more before going over to the next topic, the integration by parts.